I've now put the base only on the bed, remove the top part, and as you can see, if I zero the indicator here and move the base to the front, it is higher and higher by a lot. I'm not sure if this is intentional, but I doubt. I mean, some, but not 4/100 of a millimeter over just that short second. That means that it's pointing upwards, but I think that's too much. At least according to the Schlesinger book it is. So if we watch the lower part, this is only rough scrape just to get a pattern, and that had nothing to do with the geometry. So I just put that on, and now I'll test it, the flatness also, if at all, let's say, of any worth, before I have concluded that I have to take off and tilt this downwards, which means that I have to scrape harder on the front here. So tip scraping it and then correcting it from being up. I have devised a somewhat alternative method to using the cross slide movement to measure if this has the correct angle to the bed. Again, a smaller version of the, call it a sled, mounts here, and then a normal blade square, not this way, the other way, and then I measure here, and as far as I can see, if I put the blade shim in here, it has equal contact. So I think in fact this is square to the bed. It may indicate that the 2 to 3/100ths measured along this the tailstock ram is what is supposed to be to counteract tool pressure. Not certain, need to find out more, but at least it seems so. This is a 1/100th of a millimeter shim. Here I am trying to demonstrate an alternative way to measure up the squareness of the let's say key here to the ways, which is of course instrumental in lining up the tailstock. So I'll clamp down a normal square here, which I ride this indicator foot onto to measure up across here. I could of course have lengthened the measurement area by clamping up some piece here and also probably here, but that would also probably introduce more measurement error, or at least increase the uncertainty, because you stack up say metal blocks on top of each other, which will not be as direct as I'd like to have them, the measurements here. So I will slide this, so I zero the indicator. As you can see, this is a 1/100th of a millimeter indicator, and we run the indicator over. Is maybe 1/2 of a millimeter, which is 2/10. But then again, it's hard with this indicator to see. We may have to go to the thousandths of a millimeter indicator again. You see the point at least. For me this is probably close to 0. If at all something it deflected more, which would mean that this would be 2/10 like that way, which falls in line with the measurements I had with the tailstock in place, of course. And then the question remains if that is the correct measurement taken. Is that designed to be like that? And I am inclined to think so. But we are talking very, very small measurements here and angles or deflections or whatever you call them. And now blew it up to bed, and we'll try the fit. Here. There's no wiggle, so it's... But, as you see, okay, there it was actually very good. The guideway there, and here, so the vertical ways are okay, actually very good. But as you can see from this, it rides here, here and here. So that's why appearances are deceiving. If you think this is, well, at least looks probably nice and even, this is the proof of the pudding. Now you can see I've removed the gib here, and you can see the line. I think you can see the line at least. Yes, there it is. The gib, where the gib goes. So inside here is actually relief. So now I will test the fit to the bed again, keeping to the side. There's one side there, so you can see from the imprint here also that it's actually, I think it's making good contact. This is not perfect, probably okay, but we have a little bit here to go, and well, some more. I think 2 or 3 scraping cycles more, then we probably will have it good enough. I think I will leave it with how it looks now. It's not all 100%, at least for the video sake, I'll go with this. Now I do the same test as previously, having scraped the base, scraped it to static fit. Now everything, hope, is ready. And now if you zero the indicator and then run it to the extended barrel here, you see it's more like 1/1000th of an inch, or 2.5 hundredths of a millimeter in the right direction, pointing upwards. So a little bit of tool pressure, and also the same here. If we zero the indicator here and move it forward, we have something like 2/100ths of a millimeter, or less than 1/1000th of an inch, but also opposing tool pressure. So all this, I think, is built into the way they machined it, designed it, so it should also then have a longer life. If it wears, it wears towards being better actually. So as the tailstock gradually dips, it wears towards 0. Now I can also test, show you this again, introducing a small square there. Put pressure on the tailstock, you see it just slightly tilts from there to where you can see this side. That means it's a little tiny bit high. When I adjust the screws on the side, it tilts a little bit that way. See? That can be adjusted so this in and out. So now I mounted the tailstock. It slides freely up and down. There's no certain play. It can be, of course, be measured. You put it like this, run it up here to here, rocks, and I tried that. That's okay. And I've adjusted the levers here so they are almost in line. When this just takes a small nip to fasten. And it is solid, so I'm quite happy with how it turns out.